All right, let's get started. Thank you all for coming out. You're a lot braver than I probably would be coming to listen to me. But nonetheless, thanks for being here. I'm Steve Lee. I'm one of the space scientists here, and I think most of you have been here before. But how many of you are new? Okay, not too many, but welcome. The way this works, usually we have more than one space scientist here, and we each choose a couple of stories in space science, space exploration in the previous month and go into them in some detail. And I've got a few stories tonight. It's maybe for once we're actually going to finish within the advertised 60 minutes, but we'll see. Every time I say that, I fall in love with my voice, and it ends up being very long. So I think let's get started. We do have lots of time at the end for questions, so if you can, hold your questions until then, and we'll try to answer them. Otherwise, get my attention, and we'll do it while the slide's up. All right, could we dim the lights, Rudy? Thank you. Okay, I'm going to do a couple of Mars updates tonight, which most of you have come to expect whenever I'm here, because I'm a Mars guy. But first, I wanted to give you an update on the InSight lander. We've been talking about this. It's almost a year now that it landed just after Thanksgiving last year, so 11 months-ish. And InSight is designed to actually look at the interior of Mars. It's got a couple of cameras on board, but they're really just intended to help place the instruments. And you can see here there's two instruments on the surface. This is a very precise seismometer that is looking for evidence of Mars quakes, if you will, meteorite impacts, actual faults, slipping. So far, they think they've measured storms where there's waves in the atmosphere. So that is working fine. But the other instrument, this is called the heat flow probe, and it was designed to actually burrow about 15 feet deep, and it leaves behind a trail of temperature probes. And by having that over that distance, they can compare the temperatures at the different elevations, if you will, or the different depths, and measure how much heat is flowing out of the interior of the planet. And that tells us a lot about the internal structure. If it has a liquid core, if it has a plastic mantle like the Earth does that's also very hot. So that is what we'll mostly be talking about tonight. Both of these instruments rode to the planet on top of the deck of the lander, and then they have this relatively simple robotic arm to grasp them and put them out onto the surface, leaving an electrical ribbon cable behind. I'll show you this right now. This is a camera that is on the sort of near the elbow joint of the arm, and it's called the instrument deployment camera. And it's really designed just to help them steer this grapple fixture to get onto the instruments when they deploy it onto the surface. But the other thing you'll note here, there's this little scoop, and it's yay big. If you haven't seen it yet, you should exit through Space Odyssey tonight. We have a full-scale model of the InSight, and you can see all of these things. But I'll get a little ahead of myself here and tell you that this arm was actually left over from a mission that was scheduled to be launched in the early 2000s that got canceled. And it was sort of inherited by InSight, and it initially has absolutely no need for that sample scoop. It has no instruments on board that can measure the composition of anything or really do much of anything. But as it turns out, it's very lucky that that's on there. They left it on just because it's easier to, the arm had already been qualified in that configuration. You start taking things off, and then it's a lot more work to verify that it's going to work properly. So the instruments were all both put onto the surface successfully early this year, and then in February, the thermal probe started trying to burrow into the surface. And there's a movie in just a second, but basically this is a sort of an extra long turkey baster, and inside of it, it's got a little weight that acts like a pile driver. It's got a spring that they wind it up, and then the spring forces it down, and it bangs on the bottom and bangs the pointy end of the turkey baster into the soil. And what happened when they started doing this is in the first day of trying to deploy this, the probe stuck in place. It didn't proceed. It should have been going down about 1 millimeter every time it stroked, and it's designed to do upwards of 20,000 strokes to get down to where it needs to be, but it just stopped. And after several months of looking at this back on the ground and having an exact duplicate of the instrument, they realized that it was, first of all, probably still sticking above the surface. This was all inside this housing, so they couldn't really see it. And the thinking was that the soil wasn't behaving the way that it should, that they expected it to, based on earlier observations. Instead of the soil sort of collapsing around the mole when it's pounding itself in, it actually was very cohesive, sort of like talcum powder or plaster of Paris, where once it penetrated the surface, it just made a hole instead of the hole collapsing next to it and providing friction. And so that's what they were predicting. And in June, they reached out with the arm and grabbed this housing and lifted it up. And I think we have a movie next, I believe, that will describe this and describe what they thought had happened, and then how they expected to take care of that. I'm sorry, the movie isn't quite next. So this is the view from that camera that I pointed out right after they removed the housing. And here's the top of the probe sticking out of the soil. Indeed, it has sort of made a divot in the ground where it's not excavated, but left a hole behind that hasn't filled in. And they actually reached down with that sample scoop and tried compressing the surface and thinking that that would collapse the hole, and it did not. So now we will have the movie, and I'll explain how this has all been analyzed.
I'm Ashte Trebiolenu, and I'm the Instrument Deployment System lead for the InSight Mars lander. And as you will recall, we had a problem or an anomaly with the heat probe. After deploying it, the mole stopped penetrating, and the robotic arm and the instrument deployment system has been helping to investigate this anomaly. So this is how we've been using the scoop to help with the mole. There's a big hole around the mole, and we've been trying to use the scoop to collapse the hole. We've been using the back of the scoop to push on the hole to collapse it. We've also used the tip of the scoop to try to collapse the hole multiple times, but we've been unsuccessful. Our next attempt is to constrain the motion of the mole by pinning it to the one side of the wall. By doing that, we believe we'll constrain the motion of the mole more in the direction downward, so we might make forward progress. Here's another idea. We would use the scoop to scrape the soil to fill the hole around the mole. Then we will use the back of the scoop to compact the soil around the hole. Then we'll go back and pin the mold with the scoop. And we believe this will significantly reduce the sideways motion of the mold whilst it's hammering. As you can see, this is a very, very challenging problem. And sometimes it appears intractable, but we're engineers and we love solving challenging problems. We're cautiously optimistic that one day we'll get the mold working again.
Okay, so that was what they planned to do, and back in early July, they started trying to do this. And so here's the basically what he just showed, where there's the mole sticking out. They've come down with the scoop and pushed on it, tried dragging soil into it, and that just didn't work. And so they went off and scratched their heads for a couple months, actually. And part of that, the length of time, was Mars was on the far side of the sun, or approaching that point, and so you can't communicate with the spacecraft. So there was about a 3-week lost period in there. But in September, they started investigating doing this pinning, where they would come in and move the sample scoop hard against the side of the mole, and that would provide friction and let it hopefully move. And so starting about 2 weeks ago, they actually had some success. And so here's the mole slowly digging into the surface, and it's doing exactly what, if the soil was what they thought it was based on the original behavior, it should slightly start twisting as it moves in until it's completely in. So that was, I mean, Sol is the solar day, or the day after landing. So 3/18 was not this last weekend, but the weekend before. It's right now, it's day 328, I believe. So that was very hopeful. And what they noticed, though, is that it wasn't penetrating or proceeding as rapidly as they thought it should. If everything was behaving according to predictions, it would have been going in about 1 millimeter per stroke. Instead, it was something less than 1/10 of a millimeter. So over the course of several days of banging away multiple hundreds of times, it descended about 4 centimeters, so a little less than 2 inches. And, but it was still descending. And so this last weekend, Saturday, they'd commanded the mole to do 2 sets of 150 cycles of the pile driver. And they thought that would take it to where it actually had descended below the surface slightly. So watch carefully what has happened. And you can imagine you're sitting here getting the images back several hours after the activity occurred on Mars. And what happened, instead of going downward, it actually started retracting itself from the surface. And so let me back up here. Okay. So let's look at that again. So the good thing is it hasn't completely come up and fallen over. If that happens, game's over, because there is no way to grasp the mole. This is the little claw that helps deploy the instruments, but there's, on top of each instrument housing, there's a little ball about well, it's about the size of a gumball, and this claw grasps onto that. This is just its stowed position, and there is no such thing on the mole itself because they never anticipated having to do this. So let me just show you the before and after. This is where they were the beginning of the week when everything seemed to be wonderful, and here they are right now. This was 2 days ago. And what they're thinking has happened now is that they've actually penetrated through that very cohesive layer of soil that was causing the problems originally, and now they're in very loose, sandy stuff. And they're still working out the theory of this, but the general picture is if it's in this really loose stuff, as it bangs downward, the whole mole sort of rebounds a little bit. And when it does that, the sand just fills in the little void right at the tip of the mole, and effectively the surface is slowly pushing the thing upward, and it's not what you want to see. But what they're talking about right now is, first of all, that camera that takes these pictures, it's not steerable other than by moving the arm. So what they want to do is get on the other side of the mole so that they can sort of scope out all of the surroundings around it. And that's going to take some tests on the ground to make sure they know exactly how to raise the arm and move it sideways so that it doesn't bang into this and knock it onto the surface. They think it's got about maybe 6 inches of mole left in the surface, so it's not completely out. But then the next thought is they might try to come in from the far side here and push against it from the other side and see if they can at least get it to go back down into the hole that it had already dug, which probably is filled at this point. But that's where they are, and there's lots of very good engineers, I think, as the gentleman in the video said, that are really excited about fixing this problem. And so they've got an abundance of time. There's nothing that's going to turn this off in 2 weeks if it doesn't happen by then. The whole mission is less than halfway through its primary mission. It's expected to last at least 1 full Mars year, which is 687 Earth days. So time to solve this, but it's not dead yet. So I wanted to end for InSight with just this view from orbit. The Mars Reconnaissance Orbiter flew overhead early this month and took an image with its super high resolution camera. And this is the InSight spacecraft. And the dark area is where the rocket exhaust blew dust off the surface. And there's a slightly enlarged view, and I think I've got a really enlarged view here. But you can see the 2 solar panels, and this bright blip is that dome-like cover on the seismometer that they're able to see. And then the thermal probe is this shadow right there. So, yeah, that's a nice confirmation that the spacecraft is still there.